As we look up at the night sky, it's easy to feel small and insignificant. But did you know that the universe is so vast that it's almost impossible for us to comprehend its size? From our perspective on Earth, we can see a few thousand stars on a clear night. But what we can see is just a tiny fraction of what's out there. The universe is estimated to be around 13.8 billion years old, and it's constantly expanding. In fact, the universe is expanding faster than the speed of light. This means that the light from distant galaxies will never reach us, as they are moving away from us faster than the speed of light can travel. But despite the vastness of the universe, there is one mysterious object that seems to be attracting everything towards it. It's known as the Great Attractor. But when we look beyond our planet and into the cosmos, we realize just how small and insignificant we really are. Our home galaxy, the Milky Way, contains over 100 billion stars and stretches over 100,000 light-years across. But even the Milky Way is just a tiny speck in the grand scheme of the universe. The observable universe, which is the part of the universe that we can observe from Earth, is estimated to contain over 100 billion galaxies, each with their own billions of stars. It's a mind-bogglingly large expanse of space that's difficult for our human minds to comprehend. To put the size of the universe into perspective, let's start with the distance between Earth and our closest star, Proxima Centauri. Proxima Centauri is about 4.24 light-years away from us, which means that it takes light over 4 years to travel from our planet to the star. To travel to the edge of our own solar system, which is roughly 100 astronomical units, from the Sun, it would take over 19 hours traveling at the speed of light. Now, let's zoom out to the Milky Way galaxy. The diameter of the Milky Way is estimated to be around 100,000 light-years, which means that it would take light over 100,000 years to travel from one end of the galaxy to the other. But the Milky Way is just one of many galaxies in the universe. In fact, galaxies tend to cluster together in groups known as superclusters. Our Milky Way is part of the Local Group, which is a small cluster of galaxies containing around 54 galaxies. But the Local Group is just a small piece of the puzzle. The Milky Way is also part of the much larger Virgo supercluster, which contains over 100 galaxy groups and clusters. The Virgo supercluster is estimated to be around 110 million light-years in diameter and contains over 100,000 galaxies. But even the Virgo supercluster is just a small part of the observable universe. The observable universe is estimated to be around 93 billion light-years in diameter, which means that the furthest objects we can observe are 46.5 billion light-years away from us. The Great Attractor is located within the Virgo supercluster, which is a smaller supercluster that is a part of the larger Laniakea supercluster. But the Great Attractor is not located within any particular galaxy cluster or group. Instead, it lies in an area known as the Zone of Avoidance. But before going to know about the Great Attractor, we need to know about how scientists are able to recognize the distance of galaxies and stars in our universe. They use a method called redshift and blueshift. When we look at a galaxy, we see the light that it emits, which is made up of different colors. However, this light can appear to shift towards the red or blue end of the spectrum, depending on the motion of the galaxy. When a galaxy is moving away from us, the light waves it emits get stretched out, causing them to appear redder than they actually are. This is called redshift. On the other hand, when a galaxy is moving towards us, the light waves get compressed, causing them to appear bluer than they actually are. This is called blueshift. By measuring the redshift or blueshift of a galaxy, astronomers can determine its motion and calculate its distance from us. This is because the amount of redshift or blueshift is directly related to how fast the galaxy is moving away from or towards us, respectively. One way that astronomers use redshift and blueshift is by using the Hubble constant. This is a mathematical formula that relates the redshift of a galaxy to its distance from us. By measuring the redshift of a galaxy and using the Hubble constant, astronomers can determine the distance between us and the galaxy. In the world of science, there are mysteries that both excite and terrify researchers. The Great Attractor is one such enigma that has scientists around the world on edge. Its immense power and the unknown nature of its existence have left many perplexed and, dare I say, a little scared. So let's dive into the depths of this cosmic riddle and uncover why the Great Attractor is causing a stir among scientists. The Great Attractor is a cosmic phenomenon located in the depths of space, far beyond our Milky Way galaxy. It is a mysterious celestial body that possesses an immense gravitational pull, affecting not just our galaxy, but billions of others as well. You see, scientists are accustomed to studying and understanding the objects they observe, but the Great Attractor defies our current understanding of the universe. Its very existence challenges our knowledge of how galaxies and cosmic structures are formed and behave. Scientists have put forward various theories to explain the Great Attractor, but none have provided a conclusive answer. Some speculate that it could be an incredibly massive cluster of galaxies, exerting a gravitational force that pulls surrounding galaxies towards it. Others suggest that it could be a concentration of dark matter, an invisible substance that makes up a significant portion of the universe. Dark matter's presence would explain the gravitational effects observed, but its exact nature remains elusive. The reason why the Great Attractor is causing unease among scientists is that it resides in what's known as the Zone of Avoidance. This region is heavily obscured by the dust and gas of our own Milky Way, making it incredibly challenging to observe and study. Despite these obstacles, scientists have used various techniques and instruments to gather data on the Great Attractor. They have analyzed the motion of galaxies in its vicinity, trying to decipher the clues hidden within their movements. But each discovery seems to raise more questions than answers. The implications of the Great Attractor's existence are profound. It challenges our understanding of the large-scale structure of the universe, and it forces scientists to question the fundamental principles that govern cosmic dynamics. The unknown nature of the Great Attractor keeps scientists awake at night, contemplating the mysteries it holds. It pushes them to develop new technologies, devise novel observational strategies, and collaborate across disciplines to unravel its secrets. But perhaps the fear that the Great Attractor instills in scientists is not a fear of the unknown, but a fear of the limits of our knowledge. It reminds us that the universe is far more vast and intricate than we can comprehend, and there is still so much to explore and understand. So, as scientists continue their quest to unlock the secrets of the Great Attractor, they embrace the fear and turn it into motivation. After all, it is the unknown that drives us forward, pushing the boundaries of human understanding and allowing us to glimpse the awe-inspiring wonders that lie beyond. And so, the mystery of the Great Attractor remains, waiting for the brave souls who dare to venture into the unknown, to face their fears, and to uncover the truth that lies hidden within the cosmos. That's it for this video. Thank you for watching. See you next time.